Alrighty then, welcome back grade 9s. We are looking at chapter 8, which is on algebraic expressions. Now we're first just going to, as always, run through some terminology and just some words that you're going to hear me use quite often, just so that we can refresh your memory a bit. Okay, grab my trusty laser pointer and let's get going. So firstly, generally you get confused between what an expression is versus what a equation is. Now an expression is going to be one or more terms. We're going to get to what a term is now, but it will not have an equal sign. Okay. So an expression does not have an actual answer. The only thing we can do with an expression is simplify it, or even factorize it, that you will learn a lot later. Okay, but for now, we only care about simplification. There is no way of solving an expression. Okay, then we're going to refer to terms quite often. So what is a term? A term is a combination of coefficients. Coefficients is the number that you find in front of a variable, and variables, which again is just a letter that can represent any value, and it only involves multiplication and or division. No pluses or minuses. So in this case here, 2x, 2 is the coefficient, x is the variable. Negative 3y squared, negative 3 is the coefficient, the sign goes with the 3. Y is my variable, it is being squared, but squaring is just another form of multiplication. Even over here we've got two variables, x and y, 3 is the coefficient, and here we've got a division of a variable, but it still all counts as one term. Anything that gets put in brackets also counts as a single term. So over here, this x plus 3, if I just had x plus 3, that would count as two terms, because there is one term, there's a plus, and then there's a second term. But as soon as we put it into brackets, it counts as a singular term. And something to keep your eye out for. A constant term is just a term that does not have a variable. And you'll see quite a few of them soon. Then, we can classify polynomials. Polynomial is just a fancy word for an algebraic expression that consists out of one or more term or terms. There are special types. Monomials only has one term. Binomials has two terms. Trinomials have three terms. And that's where we end. They are all forms of polynomials. But after three terms, if there's more than three terms, we will simply refer to them as polynomials. When it comes to simplifying algebraic expressions, like terms is going to be the thing you need to keep in mind. Okay, like terms are terms that have exactly the same powers or same variables with exactly the same exponent for each of those variables. So if I have xy squared and x squared y, those aren't like terms. They have the same variables, but they do not have the same exponents for each of the variables. And quite importantly, when we're dealing with like terms, our exponents or our powers do not change. Now I'm going to run through some examples just now so you can refresh your memory here. Just a quick note on roots. In general, we can rewrite any root as an exponent. The exponent will just be a fraction. So the m on the outside, that is known as the degree of a root. So a square root has a little 2 that we generally don't write. A cube root has a 3. The degree becomes the denominator of your exponent. and then the numerator becomes whatever power was underneath the root. If there was no power, then it would just be a 1. Okay. And even if there's multiple roots, you work from the inside out, and that's about it there. With regards to dividing polynomials by monomials, so I'm dividing multiple terms by singular terms, then you need to split them all on their own denominator, the same denominator. So this one we could rewrite as, yeah, it's a bit thick, let's change that. We could rewrite this as 2x squared plus x minus 3, and each of them would then be over 2x. Right, they each have to be divided by that same denominator. And then you can simplify those fractions individually. So over here the 2's can cancel, leaving a 1. X and x squared can cancel, leaving an x. The plus stays. The x's can cancel, but that would still leave 1 over 2. And by the last one, the negative 3 over 2x, there is actually nothing you can do. Right, so that is as far as this can go. But that is how you would divide polynomials by a monomial. Again, this is all just a refresher. Let's jump into the revision exercise over here, and I'm going to go through some of this with you. Okay, so I'm going to go quite quick because it is all revision before we get into your actual new work. So, consider the following expression. 2x squared minus 8xy minus 9y squared plus 7. How many terms are there in this expression? Okay, well, number 1. It's always going to be a case of looking at your pluses and minuses. They split the terms. So there is my split in my terms. There are 4 terms. Okay, let's get rid of that, and we can say there are 4 terms. Number 2 asked what is the constant term. Again, a constant term is the one without a variable, and that is going to be 7. Please remember, whenever they ask questions like this, if it is a negative, you need to write the negative. So if this was a negative 7, you would have to write the negative. Okay, state the coefficients of the x squared term, the y squared term, the x term, and the y term. Right, let's list them out. The x squared term, the y squared term, the x term, and the y term. We need to state their coefficients. Now, the easiest way I can explain to you how to find your coefficients is going to be just scratch out the part that they are asking. So, here is my term that has an x squared in. I'm going to scratch out my x squared, and that is my coefficient. It's going to be 2. We can do the same with the y squared term. There is my y squared term. I'm going to get rid of the y squared. That leaves me with a negative 9. That will be my coefficient there. The x term is over here. If I get rid of the x, negative 8 and y are still coefficients. So that would be negative 8y. And again, for the y term, scratch out the y. That leaves me with negative 8x, so that would be the coefficient there. And yes, variables can be part of coefficients. If we're asking for just this term's coefficient, then it would be including the x. And then lastly, I cannot stress this enough, I love asking this question. Determine the value of this expression if x is 2 and y is negative 1. Please, grade 9s over here, I'll write it big as always. Use brackets whenever you are going to substitute. Use brackets. So I'm going to rewrite this entire term using brackets in place of my variables. Let's see. And now we know that x is 2 and y is -1. So let's see. Everywhere where there was an x, I'm going to put a 2. So over here belongs a 2. Over here belongs a 2. And then where there were y's, I'm going to put -1s. So over here, -1 and another -1. So there is no reason for you to get this wrong. All you're going to do from here is type it in on your calculator. So let's have a look. Let's put it on the far side here. So we've got 2 being squared minus 8, 2 times -1, minus 9, minus 1 being squared, plus 7. So the value of the expression then is 22. Okay. I'm not going to go through this. It is exactly the same thing. You are just substituting in. So use brackets. This is where I want to get to. And that's the simplification parts. Okay. So let's make some space. Actually not there. Let's make some space after that. Okay. Let's just move number 10 out the way. And again, let's get these out the way as well, because we want to focus on just the 1. We've got an m cubed plus 3m cubed plus 4m squared. Now remember, these are all the same bases, they are all m, but remember your exponential laws only talks about multiplication and division or raising powers to powers, nothing about addition and subtraction. When addition and subtraction is involved, you are not going to use any exponential laws. First general mistake is you tend to forget that this is 1m cubed. If it was a 0, then the whole term would be gone, but it is 1m cubed. Secondly, we need to identify our like terms. What do we know about like terms? They need to have exactly the same variables with the same powers for each of those variables. So this positive 4m squared does have the same variable but not the same power. So it is not a like term. So the only ones we can add is the 1m cubed plus 3m cubed. 1 plus 3 is 4m cubed. And the 4m squared just stays there. There's nothing more you can do. Don't try and force it. Don't try and add them. Don't try doing anything here. There is nothing extra you can do here. Okay, so that's how this stays. Let's grab number 4 so we can have a look at it. Number 4, we've got a -8x cubed minus another 2x cubed. Now luckily these are both like terms. They are both x cubes, and the signs as always go with the terms in front of them. So we can add them both together. Let's just get this back to where it belongs. There we go. A negative minus another negative is going to just add together. -8 minus 2 is -10. And again, my powers do not change. Over here, the cube didn't change. Over here, the cube is not going to change because we are not multiplying, dividing, or raising to a power. It's only when you use exponential laws that your exponents will change. Let's grab number 7. Now here's something else happening before we can look at like terms. So here's an addition, but here's multiplication, and BODMAS still counts. So we need to multiply these two terms together. I'm actually going to highlight it. This is where we're going to start. And over here we will use signs, numbers, variables. That's what we use to multiply. different terms. So signs first, we've got a positive 3 and a negative 5. A positive times a negative is a negative. 3 times 5 is 15. D times d cubed, we just did exponents. It's d to the power 1. Multiplying the same basis, we add the powers. 1 plus 3 is 4. So that's d to the power 4. And the plus 6d to the power 4 stays. Now they are in actual fact like terms. This time I'm just going to underline them, because they both only have d as a power or as a variable, and each has exponent of 4. So we can just add the coefficients. Minus 15 plus 6 gives me negative 9 d to the power 4. Okay, so this time it could work out to one term, to a monomial, but it is not always going to be the case. Let's look at number 10 quickly. Now here, I need you to pay attention. We are raising powers to powers, so here we are actually going to use our exponential laws. This multiplication of 3 here comes after the power. So firstly we need to use our exponential laws. So this power of 3, let me change colors first. This power of 3 needs to go to this base of a squared, and in the second part this power of 3 has to go to a coefficient and to the base. So what's going to happen here? This 3 is going to stay. I'm going to leave it in a bracket. A squared cubed, raising a power to a power, we multiply the exponents. 2 times 3 is 6. Dot's going to stay there. You can change it to a multiplication if you want to. So I'm going to leave my bracket here. 3 is going to get the cube. So that is going to become 3 cubed, which is 27. A squared cubed, again, power to a power, 2 times 3 is going to be 6. Okay, now we've got multiplication, and there's 3 things being multiplied here. So we can actually multiply straight through. 3 times 1 times 27 is going to be 81. A squared, no, a to the power 6 times a to the power 6, multiplying the same basis, we add the exponents, and we get to a to the power 12. What you'll notice of number 10 is there were no pluses or minuses. This was all one term. It was powers, it was multiplication. There were no pluses and minuses between the terms. So this counts as one term. That's why we ended up using our exponential laws. Okay. Let's look at D. Now D is going to have a look at your distributive property. I'm only going to do number 1. I'm going to ask you to do 4 and 7 in class. Same by E, I'm only going to do the first one, number 2, and same by F, I'm only going to do the first one and ask you to do the rest in class before we get onto the real new work for you, since this is all revision. So over here by D, this is just a case of distribution. These are not like terms, so we can't do anything. So the only thing we can do there is distribute the negative. So that means the negative times the positive here will give me negative m squared. The negative times the negative will give me a positive 3mn. And again, don't try and force it. This is an m squared. This is an nm. They are not like terms. That's how it's going to stay. Okay. Like I said, the other two I'm going to ask you to have a look at. In question E, I'm just going to do this one. Now here you will notice that again there are no pluses and minuses. This counts as one term. There's nothing in front of it that makes it 2 terms. It counts as one term, so this is technically an exponents question. But I'll go through it regardless. The 2 needs to go to the negative, or not the 2, the square, to the 5, to the base of m, to the base of n. Over here the 5 is in front. The square needs to go to the base of m and to the base of n. So let's sort that out quickly. A negative being squared is going to be positive. 5 squared is 25. M cubed squared, 3 times 2 is m to the power 6. N to the power 4 to the power 2, 4 times 2 is n to the power 8. At the bottom, the negative 5 just stays. M has a power of 1. 1 times 2 is m to the power 2. N to the power 2 to the power 2, 2 times 2 is 4. And then we can apply our second law. Positive divided by a negative is a negative. 25 divided by 5, 5. N squared, we can again divide the same basis, subtract the smaller power from the larger one. 6 minus 2 is 4. Larger power was in the numerator, so I'm going to put my answer in the numerator. N to the power 8 over n to the power 4. 8 minus 4 leaves me with n to the power 4. Larger one was in the numerator, so again power goes in the numerator. And that leaves us with nothing in the denominator, so we don't have to write a denominator. Okay. And then for question F, we've got the root of 4x squared. We are going to split this up. And you've got actually more than one option to do this, but I'm going to split this up. Whenever I have things being multiplied under a root, I can split them. So I can say that this is exactly the same as the root of 4 times the root of x squared. Okay. Now, please be careful, you cannot do that here. That's being added. Remember, if there's an operation like a plus or a minus under a root, we treat it as if it's in brackets. It has to happen first before we can take the root. However, with multiplication and division, we can split them. And then it becomes easy. The root of 4 is 2. The root of x squared, square root just cancels a square, so that becomes x. Okay. So we're going to look at some of the rest here. And I'm going to ask you to go through some of it in class before we jump into your new work.